Artificial intelligence is this umbrella term for a couple of different advancements in computer science. AI is the concept of machines doing tasks or learning tasks that were historically human-based. They required human intelligence in order to complete the task. Artificial intelligence is a machine accomplishing those tasks. Some common examples of AI that you may not realize is artificial intelligence or AI. Netflix and Siri. Those are two. The way that they operate, the way Siri works and the way that Netflix works, they're artificial intelligence. Artificial intelligence can be broken into two major fields. First, applied artificial intelligence. Applied artificial intelligence is designed to complete a specific task, right? It's applied. Like, this is a problem that I want to solve, and I'm going to develop this machine or this computer program to do that task or to solve this problem. The second field is general artificial intelligence, and that is artificial intelligence that's designed to complete any task. This type of artificial intelligence learns as they encounter new things. So general artificial intelligence kind of gave rise to this subfield that we call machine learning. If you think of artificial intelligence as the umbrella term, the next smaller umbrella would be machine learning. Artificial intelligence that is built with machine learning is not reliant solely on the code of its creator, right? So the way that these programs work is someone who is knowledgeable in computer science and is able to write code or program for that matter. The machine operates on that code, but it can also write its own code and learn as a human would. And this idea can seem really foreign, but it's happening right now. There's concepts such as facial recognition, voice command, and translation of languages, and this is machine learning. So when you use your face to unlock your iPhone, that's machine learning. Your phone is a machine learning who you are, what you look like, and that's how it works. That's how it can unlock your phone, because it can recognize. Previously, I had mentioned that I had to take this class in college, and one of the major projects in this class was a project called LifeNaut. LifeNaut is a online software that you can sign up for and you can use. Like, if you want to right now, you can go to lifenaut.com. Not a sponsor, but if you go to lifenaut.com, you can create what I'm about to talk about. But for class, we had to create what was called a mind file. A mind file is a copy or duplicate of your personality and your traits. The way that we obtain or create a mind file is LifeNaut has this AI robot that you talk to via text chat or voice chat. And the more you talk to it, the more it learns your language and the way that you act and your personality and your opinions on things. And as a result, it does its best to mimic you. And as it's mimicking you, it's saving all of this data. So if I were to die and someone wanted to interact with me after I was dead, they could refer to my mind file on LifeNaut, which is like super creepy to think about. And the fact that like people are out there doing it like today. This was 3 years ago that we had to do this project. So it's happening. I just went on the LifeNaut website again for the first time in like 3 years as I was doing my research for this episode, and they have made more advancements on the website. But if you're interested in that and you kind of want to see what it's about and how it works, go ahead and check it out, lifenaut.com. I'll put a link down below. This kind of segues into the next topic in artificial intelligence. That topic is deep learning, right? So we have the umbrella, artificial intelligence, the subfield, machine learning, and even more niche, even more of a subfield, we have deep learning. Deep learning takes learning like the machine learning concept where a machine is writing its own code as it learns new tasks. It takes that to a whole new level where this machine is now trying to mimic human behavior and intelligence. The way this works is by what we call a neural network, almost like neurons and the neural network that we have, except this one is a programmable one. Last week we talked about neurons, but when we talk about a neuron here or a neural network, it's a programming network. And a neuron in this case is a binary question. So the more neurons or binary questions we create and layer on top of each other, the more outcomes we produce. This is an exponential process, and it can create a very, very deep code, thousands and thousands and thousands of layers deep. Here's a really good example of how neural networks work. Okay, so we want to create a neural network that can determine if a photo is of an apple or a banana. So we program 3 questions into the neural network. The first, is the object in the photo round? That's a yes or no question that can be identified and can be programmed to figure that out. The machine is able to identify round versus not round. The second question is the object yellow? The third question, does the object have a stem? So if we fed this machine or this neural network a photo of a banana, the answers to the questions would be no, yes, no, right? No, the object is not round. Yes, the object is yellow. No, the object does not have a stem. So we can translate these no's and the yeses to numbers, zeros and ones. So when you see references to ones and zeros in computer science, that's binary code. That's what we're talking about here. So for the banana, the binary code would be 0, 1, 0. 0 equals no, 1 equals yes. And the same goes for the apple, except the questions would be opposite. Is the object in the photo round? The answer is yes. Is it yellow? The answer is no. Does it have a stem? The answer is yes. As a result, the binary code is 1, 0, 1. Now, if we take this concept and go 1,000 times further, or 1,000 steps further, we are able to create a deep learning neural network. And as futuristic as this sounds, it's happening right now. There are deep learning networks out there, and they're very useful. An example would be image recognition. If you might have noticed, you might be, if you go on the web browser, Google, you can click on a photo or insert a photo, and it can search related photos. That's a deep learning network, right? So that's something that is understanding what image you're feeding it, and then it's able to produce similar patterns or similar photos. It's also used in voice recognition, and it can now predict customer preferences, it can detect fraud or scams, and it can even conduct life-saving diagnoses in medicine. Essentially, anything a human can do is within the scope of a deep learning network.